And so it begins.
10-5, the distance formula. The distance formula is based on the Pythagorean Theorem. If you look to the model that's on the right hand side of your screen here, right over here, okay, then you'll see that the distance here is actually the hypotenuse of a right triangle, okay? And that's what we're going to use to establish our distance theorem, distance formula. So the distance d between any two points, say A and B, that have coordinates x1, y1, and x2, y2, is given by this formula here. D is equal to the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Okay, let's do an example. Let's do example 1. And that's on page 555. And it says find the distance between 2 points at 2, 3 and -4, 6. All right. Now, what I recommend is that you assign the x1, y1, and the x2, y2 to these points, because it will help eliminate confusion later on. So here's x1, y1, and we're going to set that equal to 2, 3. And here's x2, y2. I'm going to set that equal to -4, 6. Now, does it matter which point is which? It does not. As long as you do the math correctly and hold the PEMDAS, you will come out with the right answer. Okay, so our formula says d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and all the square root of that. So really what we do is we just drop values in and plug and chug. So d is equal to the square root of x2 happens to be -4 minus x1, which happens to be 2, and we square it. And then y2 is 6 minus y1, which is 3, and we square that. Okay, so this is equal to the square root of -4 minus 2 gives you -6 squared, plus 6 minus 3 is 3. This gives you 3 squared. So this is the square root of -6 quantity squared is 36, plus 3 squared is 9, and that gives you the square root of 45. Okay, which we know through prime factorization becomes, so this becomes 3 squared times 5, an awful 5. So this becomes 3 square root of 5. So d is equal to 3 times the square root of 5. Now notice that this is an exact number. D is equal to 3 times the square root of 5. But as soon as you drop this down into decimal land, then you have issues. Not issues. Then you have rounding problems, and you have accuracy issues. So this is approximately equal to 6.71 units. All right. So the exact answer, sorry about that, the exact answer is 3 times the square root of 5. The approximate answer is 6.71. At your level, it really doesn't make a hoot which one is which. But when you're an engineer, there's a big difference between these two numbers. Let's try another example. Let's do example 2. Right here. Example 2 on page 556. All right. Now I've cut and pasted the words of this into the problem, into our notes here to make it easier. So Tracy's golf ball is 20 feet short and 8 feet to the right of the cup. On her first putt, the ball lands 2 feet to the left and 3 feet beyond the cup. If the ball went in a straight line, how far did it go? Okay. Now, the hard thing about this right here is modeling it. You have to visualize what they're telling you here. So, where is the center of this picture? Is it where her ball first is? Is it where her ball ends up? Or is it the cup? Alright? Well, it's the cup, because if you read it, it gives you 20 feet short and 8 feet to the right of the cup. And then on the second sentence, it's 2 feet to the left and 3 feet beyond the cup. So the cup is the center. So you have the cup, and now the first one says it's 20 feet short and 8 feet to the right. Well, if the cup is the origin, what is off to the right-hand side of the origin? That's the x-axis. That's positive x. So you would go over positive x 8 feet, and now it's 20 feet short. Short usually means negative. So you'd go over 8x and down 20y. And that would be the initial position of the ball. Then the origin is the cup, and then it says it goes 2 feet to the left and 3 feet beyond it. So, what's 2 feet to the left of the origin? That's negative x. So you go 2 negative x, and it's gone past the cup, so that's 3 up in the y direction, because it's going in a straight line. Alright, that's how you model this. So I too put this, cut and pasted this into our presentation, but I hid it or deminimized it so that we could play around and play around with the model a bit. Okay, so here is first position. Alright, here is the cup, and then here is the second position. We want to find out how far did it go. Well, we know that the first point is at 8, 20. So we'll let that equal, 8, negative 20. We'll let that be x1, y1. We know that the second point then, the end point, is at negative 2, 3. And we'll let that equal x2, y2. And then we have our distance formula. Whoops. x2 minus x1 squared plus y2 minus y1 squared. Okay, and that becomes the square root of x2 is negative 2 minus x1, which is 8 squared, plus y2, which is 3, minus y1, which is negative 20. And that quantity squared. Okay, so coming down here and simplifying the terms under the radical, negative 2 minus 8 should give you negative 10, quantity squared, plus 3 minus a negative 20 gives you a positive 23 squared. Okay, so this becomes the square root of 100 plus 529, which is equal to the square root of 629. Okay, this is from the magic of looking in the book. It's like 25, it's approximately equal to 25.01 feet. So what we do is we simplify it to approximately 25 feet. All right. So, I mean, either 25.01 or 25 would be acceptable on the test if I didn't tell you to round it. Okay. Okay, example 3. Example 3 now on page 556. Now Now this is a different kind of distance formula usage, and this is called find a missing coordinate. Okay, here it says find the possible values of a. So here's a variable a. Find all the possible values of this a if the distance between these points 7, 5 and a, -3 is 10 units. Okay, so our distance formula still holds. We still have d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we need to still have x2s and x1s and y2s and y1s. So x1 comma y1. We're going to let that equal 7 5. And for x2 comma y2, we're going to let that equal a comma -3. Okay, so coming down over here, oh, there is one more. Guess what d equals? That's right, 10 units. In this case, we have the d. So we come over here and we say 10 is equal to the square root of x2, which happens to be a, minus x1, which is 7, squared, plus y2, which is -3, minus y1, which is 5, squared. Okay, so then this becomes 10 is equal to the square root of a minus 7 squared plus -3 minus 8, or -3 minus 5 is -8. That quantity squared. Alright, let's simplify it one more step then. 10 is equal to the square root of a minus 7 squared plus 64. Okay, so we just got through dealing with radical equations, and we know that when we have an equation that has a radical in it, we know what we need to do to get rid of the radical sign, right? So let's come over here and do this thing. 10 is equal to the square root of a minus 7 squared plus 64. We square both sides of this equation. Okay, so 10 squared is still good old 100. When you square a square root, what's under the square root simply comes out. A minus 7 quantity squared plus 64. So let's simplify this radical here. We have 100 is equal to a squared minus 14a plus 49. I'm going to make the negative sign a little better. Oh, and we forgot one. Plus 64. Alright, let's come back over here. We have 100 is equal to a squared minus 14a plus 49 plus 64 is plus 113. So now we're going to subtract 100 from both sides. This goes away. And we're left with, over here, 0 is equal to a squared minus 14a plus 13. Alright, now we have to factor it. So what two things multiplied together give you 13 and added together give you 14, negative 14? Yeah, I think you know. 0 is equal to a minus 13 times a minus 1. That's right. From our zero product property, then we know that either a minus 13 must equal 0 or a minus 1 must equal 0 or both. So in this case, a then would be 13. In this case, a then would be 1. So to answer your question then, at the very beginning that it asked, a would be equal to 1 comma 13. Those are all the values of a that will make this a true statement. Thank you for listening. If you would, please comment down in the comment area that say that you watched this, so that I know who has watched it and who has not. If you want to like it, that's great. If you don't, I won't be hurt. But I do want you to comment in the comments below to say that you have watched it. Thank you, and I will see you next time.